Right, okay, so this wee video is going to be about flowcharts and programmable systems. Um, let's stick where the kind of where the big marks are. The big marks are in flowcharting, so let's deal with that first of all. The main part about flowcharting is the symbols. When you do a flowchart, well, it's not really the main part. The main part is getting everything in the correct order. You know, when you look at a flowchart, you're going to see, if you look at it like an answer, you're going to see something that looks like that. You know, with different shaped boxes appearing, and the shape of the boxes is chosen depending on like a sequence that you are given. Very possibly that could do something like that. You know what I mean? And be writing in all these boxes. So that's what a flowchart kind of ends up looking like. All right. When you're finished, if you've got everything correct, if all the shapes of the boxes are the correct shape, that's like 1 mark. You get 1 mark for getting all the shapes correct. And the rest of the marks in a flowchart in question come from making sure that the things are all in the right order, the text within the boxes is the correct text, and that the arrows are all taking the flow the correct way. Notice with decision symbols, you've got yes and no in there. That could be a separate mark as well. Did you get all your decision symbols labeled correct? So this is the kind of thing that we're looking at, right? So let's look at it in a little bit more detail. All of the shapes, you've got a reminder of all the shapes in the data book, right? So just to clarify, when if you're looking for any of the engineering science documents, right? When you sign into Glow, you've got these two launch pads. You've got the Airdrie Academy launch pad and you've got your own personal launch pad. I've tried to make sure that everybody's got an engineering science tile on their own launch pad, but they might not have. If you don't, I'll show you where to find it. So in the Airdrie Academy launch pad, there's a tile called SharePoint. When you go into that tile, you've got an option on the left hand side here for site contents. You've got an option here for subsites. And engineering science is right on the top there. Okay, so when you go into engineering science, you've got a timeline and stuff, different things. But you've got a documents repository, and that's quite important. This is basically like the pupil share drive, but accessible from anywhere. So in this drive, you'll find um, the National 4.5 data booklet. If you have a look inside the National 4.5 data booklet, on I think it's the last page, gives you a reminder for the symbols for flowcharts. So Terminator use that for start and end of them. Um, Input and outputs, process symbols, decision symbols, and sub-procedure symbols. So let's kind of break that down a little bit in detail. So you saw that quick sketch I did over there before. A lot of times in the question, they give you the start bubble. They give you that start terminator in the question, and you just have to continue on from that. If your flowchart comes to a complete end, which is it's unlikely, not a lot of systems have a sequential flowchart that runs all the way to something that says end. That's quite uncommon. It's possible, but very uncommon. It's possible you might see something like that, right? The other boxes that we use rectangular boxes. I'm not going to sketch a rectangular box. I'm going to draw a rectangle here. Rectangular boxes are used for processes that happen inside the microcontroller. So as far as we're concerned, microcontroller. As far as we're concerned, that's things like delays, waits, and it could be things like setting counter values. Alright, so you might expect to see in there, you might expect to see something like wait 1 second. Super important that if you're doing delays, should always include the units of that delay. Don't just say wait 1, you say wait 1 second or wait 1,000 milliseconds or whatever. Another box that we use in a data book, it says that this is for inputs and outputs. So this is a box that we primarily use. Notice it's always going to have one arrow in and one arrow out. That we primarily use that for things outside the microcontroller. Specifically for us, that's turning pins on and off. Alright. So you would expect to see a representation of the sequence in there. Now, I've got a I've got a question open. I just want to kind of, what am I pressing there? Oh, I'm pressing the wrong thing. Oh, I'm all over the place. Right, so here's like an old flowchart question. And this is common to see this, where you see a sequence that the microcontroller is going to have to follow, because remember that's what microcontroller is essentially doing. It's just following a set of sequential instructions. And then you get this kind of matrix that tells you, for the pins on the microcontroller, what device is connected to which pin. You can see at one point in here, it says the mixer motor runs for 10 seconds and then stops. You can see that the mixer motor is on pin 5. So you might think that you could go mixer motor on, wait 5 seconds, mixer motor off. Yeah. And that would be that small part, just that wee bullet point there is covered by those 3 parts of the flowchart. You'd have to be really, really careful about the question, okay? Go on to the next page. In fact, this one is complete the flowchart. You can see there, mixer motor on. Oh, did I put 5 seconds instead of 10 seconds? That was daft. Mixer motor on, wait 10 seconds, mixer motor off. There's that bit there, okay? And it's completely okay that it's got mixer motor written in there. However, more kind of modern questions aren't asking you to complete flowcharts. They're asking you to write flowcharts. And you're going to have to be really, really careful with that, because, just try to flick through to see if I can find one. This is a more modern one here. Now, that last sentence, include all pin numbers in your flowchart. So in this one, it says, if the cards means that the speed display sign is switched on for half a second, so that might lead you to go speed display sign on, wait for 0.5 seconds, speed display sign off. But the last sentence in this question is include all pin numbers. Can't do that. More often than not, inside these squinty boxes, we don't tend to see the names of the device. We tend to see the pin number that it's connected to. Pin 5 on, pin 5 off. It's a really important distinction, and you need to be really, really careful of that, because it's really, really easy to lose marks in doing that. If you don't put the pin numbers in, there's no marks for the contents of that box. So be very careful with that. Read the question carefully. Okay, so we've got start terminators, we've got the rectangular boxes, we've got the squinty boxes, we've got decision symbols would be the next one. Have I got a decision symbol? There's a squinty box. I could have used that squinty box, but I don't have a decision symbol. Fantastic. Right, okay, so a decision symbol is a diamond shape. And this is what we use to ask questions. There's always one in, there's always 2 out. The only question we can ask in here is a yes/no question. It's important that whenever you draw a decision symbol, you've always got 1 going in and 2 coming out, and you always label the yes and no, right? It's typical in here, we would use this. So this is a decision symbol, and it's for, or to ask yes/no questions. Okay, typically to test inputs. Is pin 1 on, is pin 0 on? Or to test counter values. Have we done this 7 times yet? The answer to that question is yes or no. Is pin 1 on? The answer is yes or no. So it's typical to see this kind of thing. Pin 0 on. And you've got a yes or no in there. So that's the kind of the main content of the stuff that you would see. Let's actually do a little example here out of these past paper questions then. Let's keep it simple. I'm going to choose one that's kind of relatively simple. Hold on. Right, okay, so let's actually get a look at this question here because it seems relatively straightforward. Um, when you read through the sequence, it's got a sentence in it that's like when a start switch is activated. Yeah, that's somebody pressing a button. So straight away we know there's going to be a decision symbol there because that's how we test switches. After 1.5 seconds, there's a delay. It's going to be a rectangular box with 1.5 seconds in it. The dinosaur will roar for 1 second. So there's the roar pin. So pin 1. So after 1.5 seconds, pin 1 comes on for another 1 second. And then at the end of that, after that 1 second, um, after that 1 second, you think it doesn't actually explicitly tell you that the roar goes off. You're just assuming that the roar goes off. It says it'll roar for 1 second. After another 0.5 seconds, the arm should halt. Step 2 and 3 will then repeat 3 times. So we've got a counter in there as well. You know, has this been done 2 times? Has this been done 3 times? So we're testing switches. We're counting. So there's going to be decision symbols in here for a bunch of stuff. There's going to be rectangular boxes controlling arms and roar, and there's going to be delays, right? And it says the sequence will then repeat. So that means we don't need an end terminator. It's going to just go back to the start. We've got this kind of nice matrix box in here that tells us what's connected to what. As soon as you see start switch, as soon as you see anything that's a switch, a sensor or whatever, there's going to be a decision symbol for that if it's included in your sequence. Okay, so let's actually do this then. I'm going to cut that into a wee sketch pad. And the question does say complete the flowchart with reference to the table of input and connections. Include all pin numbers. All right, you can see it's 8 marks. The flowchart questions tend to have a lot of marks in them. They're high value questions. Let's stick this in here and get a quick look at it then. Okay. Chances are in the actual exam paper it would have given us that start bubble. If it doesn't, it's okay, we can draw it. So the first thing that happens is when a start switch is activated. So that means the first thing that's going to be happening is pin 0 is going to be getting checked. It's that old decision symbol, pin 0 on, question mark. Has the start switch been pressed? It's a slightly different way. If it hasn't, we just want to keep checking it. That's called a polling loop. Nothing's going to happen until the switch is pressed. Fantastic. So when the start switch is activated, the arms move. So pin 2 comes on. Pin 2 on. See how important it is to engage with this information and different. This is the important stuff. And this. So pin 2 on. After 1.5 seconds, the dinosaur will roar for a second. Oh, I've made a mistake. I've put a rectangular box in. Oh, for goodness sake. How did I do that? As you can tell from my voice, I'm not feeling very well, so I'm going to blame this horrible sore throat that I've got. Right, okay, so wait 1.5. 1.5 seconds. Make sure you put those units in. So after 1.5 seconds, the dinosaur will roar for 1 second. So roar comes on. So that's pin 1 on. And that's a squinty box. And it's on for 1 second. Wait 1 second. Yoink, rectangular box. Pin 1 off. That's it, finished roaring. And then there's another half a second, and then the arms stop. Oh. Can we remind pupils? So there's another half a second delay. Wait 0.5 seconds. So after another half second, the arms should halt. So that's pin 2 off. It then says that steps 2 and 3 will repeat, so that's the 1.5 seconds. You need to be careful with that. After 1.5 seconds, the arm should halt. It does say step 2 and 3, so that means we're coming back to do 2. There's 2 there. Right, so we're going to do a repeat for 3 times. So then the question is, has been done 3 times. Doesn't really matter what you write in here. Has this been done 3 times? And if the answer is no, then we're coming up to repeat step 2 and 3. And if the answer is yes, then we are repeating the entire thing. There you go. It's important that you've got a no there with an arrowhead on it. Every line should have an arrow on it. Yeah, let's get an arrowhead on it. That's us finished. So that's what a typical flowchart ends up looking like. So you get 1 mark out of those 8 marks, right? You're going to get 1 mark for having a decision symbol in for that pin. You're going to have 1 mark for having a decision symbol in to check that it's been done 3 times. You're going to have 1 mark for having all your weights in the correct order at the correct value with the units in. You're going to have 1 mark for having pin 2 on and off in the correct place. You're going to have another mark for having pin 1 on and off in the correct place. You're going to have 1 mark for all the shapes being right. Yeah, that's 6, another 2 marks. You're going to have 1 mark for having a loop back to the start again. And you're going to have another mark for having this 3 times loop coming back to the right place. That would be the 8 marks, I would imagine. Okay, so that's how we do flowcharts. What I'd like you to do is get into this document and have a look at another one. Specifically, maybe, let me just kind of try to pick one that's kind of the same. It gives you a wee start in there. When the host presses a question, when the host presses a timer. Well, so there's 2 switches in that one. Buzzer will sound for 2 seconds. Yeah, this one here seems like a question that's feasible to do. Okay. Cut and paste that so you can get it all in the one screen at the one time. Give me a sec. Right, so there's the full question there, and there's what everything's connected to, and they gave you a start. So they said it was start, and they actually gave you the first decision symbol. And the host presses a question switch, so pin 0, pin 0, 1. That was the start that they gave you. Just checking it, make sure. Yeah. Right, so I would ask you to go ahead and do that question. It's very similar. So you've seen one done. Again, this is recap. This isn't the first time you've seen it, and this won't be the first one you've done, but it's to the similar standard that you're being asked to do. There's a wee bit of difficulty in this one with this kind of math. The LED will pulse on and off 16 times over an 8-second period. So at one point in this question, you're going to have LED on, wait, LED off, wait, 16 times. Right, so you're going to have that obviously filled in properly. This is to happen, so that this 16 times, this is to last 8 seconds. So that means one time through this loop has got to be a 16th of 8 seconds. 8 divided by 16 seconds. 8 divided by 16. So half a second. So one time through this loop has to last half a second. You've got 2 delays, so you just split them evenly. Split that half a second evenly between those 2 delays. That's it. Okay. We'll do another video where we talk about, the kind of benefits of microcontroller architecture and stuff. But flowcharts is, there's a lot of marks in flowcharts. Thank you.